All right, today we're taking a grand tour of our solar system. We're going to journey from the incredible stars smack dab in the center all the way out to the mysterious, icy objects at its very, very edge. So, are you ready? Think of this as your own personal guided tour. We've got a ton to see. I'm talking worlds hot enough to melt lead and frozen giants bigger than you could ever imagine. All right, let's do this. Okay, first things first. Every good tour needs a map, right? So before we really jump in, let's get our bearings. Let's figure out what exactly makes up our solar system. You know, our solar system is this wonderfully bustling neighborhood. At its heart, holding the whole thing together, is our star, the sun. And orbiting it, you've got 8 planets, literally hundreds of moons, 5 officially recognized dwarf planets, and millions of asteroids and comets. And all of it is just swirling around in this cosmic sea of gas and dust. It's an incredible system, and we're about to explore it all. So our journey has to start right at the heart of it all, the sun. And look, it is so much more than just a bright light in the sky. It's the anchor of our entire solar system. It's the powerhouse that governs everything with one single, incredibly powerful force. And that force, it's gravity. I mean, get this. The sun contains over 99% of all the mass in the entire solar system. Because of that, its immense gravitational pull is basically the law of the land out here. It keeps every single planet, asteroid, and comet locked in its own path, just endlessly circling. Okay, so here's a question for you. Why do the planets orbit the sun instead of just, crashing right into it? Well, to really get our heads around that, we're going to use a famous thought experiment from Isaac Newton. It is the perfect tool for explaining the mechanics of an orbit. All right, so just imagine this with me. Newton pictured a cannon on a mountain so tall it's basically in space, above all the air. First, you fire the cannon. Gravity, of course, pulls the cannonball down. That's path A. Simple enough. Now, fire it faster. The ball travels way further before it lands, right? That's path B. But here's the magic trick. If you fire it at the perfect speed, and I mean perfect, that's path C. The cannonball is still falling towards the Earth, but the Earth's surface is curving away underneath it at the exact same rate. So it's constantly falling, but it never lands. That, my friends, is an orbit. It's the exact same idea that keeps the Earth circling the sun. Okay, so now that we've got the rules of the road down, let's visit our first planetary neighborhood. We're talking about the dense, rocky worlds all huddled up close to the sun. So here they are, the terrestrial or Earth-like planets. You've got Mercury, Venus, our home planet Earth, and Mars. And they all have one big thing in common. They're small, dense worlds with solid, rocky surfaces you could actually stand on. Now, here's something really interesting about this inner neighborhood. It's a bit of a puzzle. You would think that Mercury, being the closest to the sun, would be the hottest planet. Makes sense, right? Nope. That scorching title actually belongs to Venus. Its super thick, toxic atmosphere has created this runaway greenhouse effect, trapping heat and just roasting the surface. We're talking hot enough to melt lead. It's a pretty powerful reminder of how much an atmosphere can change a planet. And hey, before we travel any further out, let's quickly talk about moons. Because they're pretty scarce around here. In this whole inner region, only Earth and Mars have any. We've got our one big, familiar moon, and Mars has these 2 tiny, kind of potato-shaped moons named Phobos and Deimos. All right, buckle up. It's time to travel much further out. We're going to cross a great divide in our solar system and head into the realm of the giants. Welcome to the outer solar system, home to these colossal worlds made of gas. Out here, we find the 4 gas giants: Jupiter, Saturn, Uranus, and Neptune. And these are a completely different kind of planet. I mean, they are absolutely massive, made up mostly of hydrogen and helium gas, and, get this, there's no solid surface to stand on whatsoever. Jupiter is the undisputed king of the planets. It is so big, you could fit all the other planets inside of it. Then, of course, you've got Saturn, famous for those absolutely stunning rings, which are made of countless little bits of ice and rock. And hey, here's a cool fact for you. You don't even need a massive telescope to do some exploring out here. You can actually see Jupiter's 4 largest moons with just a good pair of binoculars from your backyard. And speaking of moons, remember how the inner planets had like 3 between them? Well, it is a totally different story out here. These gas giants are basically moon-collecting machines. Saturn alone has 82 confirmed moons, and scientists are finding more all the time. It just goes to show how wildly different the inner and outer solar system really are. Okay, let's just pause here for a second and take a look at this because it really sums up the two completely different families of planets we've just visited. You've got the small, rocky worlds close to the sun with hardly any moons, and then you have the massive gas giants way out in the cold with tons and tons of moons. The big takeaway here is that our solar system isn't just some random collection of worlds. It has a very clear structure. Okay, for the final leg of our tour, we're heading out to the fringes. We're going to the cold, dark, and deeply mysterious edges of our solar system, which is home to some of its most fascinating objects. So, remember that Great Divide I mentioned we crossed to get to the gas giants? Well, that is the asteroid belt. It's this huge ring of millions of rocky objects just hanging out between the orbits of Mars and Jupiter. It's the clear boundary separating the small, rocky planets from the huge gas giants. But the fringes have a lot more than just asteroids. Way out here, we also find comets. People often call them dirty snowballs. They're these icy bodies that swing in from the outer darkness on these really long, oval-shaped orbits, and they grow those spectacular tails as they get closer to the sun. And then, of course, you've got the dwarf planets, like the most famous one, Pluto. These are basically small, round worlds, big enough for their own gravity to make them spherical, but just not quite big enough to have cleared out their orbits like the 8 main planets did. And if you want to really appreciate a comet's epic journey, you've got to look at Halley's Comet. This thing is a true celestial celebrity. I mean, it was recorded in the sky all the way back in 1066, before the Battle of Hastings. It takes about 75 years to complete one long loop around the sun. We last saw it back in 1986, so you can go ahead and mark your calendars for its big return in 2061. Now, our tour has really focused on the natural wonders of our solar system, but it just wouldn't be complete if we didn't talk about the fact that we've also sent our own explorers out there. We've built these incredible machines, from the Hubble Space Telescope, which gives us those breathtaking views from Earth's orbit, to robotic probes like Rosetta. And Rosetta didn't just fly by a comet, it actually chased one down and landed a craft on its surface. Just amazing. And maybe the most, romantic and ambitious of all our explorers is the Voyager 1 probe. It was launched way back in 1977. Since then, it's traveled past all the outer planets, left our solar system completely, and is now just drifting through interstellar space. And on board, it carries this golden record. It's like a time capsule of Earth's sounds, music, and greetings. It's literally a message in a bottle cast out into the cosmic ocean for whoever or whatever might find it one day. And with that incredible thought of our own little message just drifting through the stars, our tour comes to a close. We've seen the incredible diversity, the structure of our home system. But what's so exciting is that this journey of discovery, it's really only just begun. And that leaves us with the biggest question of all, doesn't it? Where do we go next?